Hey guys, welcome back. So what we are looking at today is lesson 5. So let's go ahead and jump right in. What we're going to be dealing with is looking at how subtraction with negatives. So understanding that, understanding and being able to explain that subtracting is equivalent to adding its additive inverse. So let's jump right in. So here is an unfinished number line diagram that represents the sum of 8. Let me make this smaller quick. So we've got this 0, it goes to 3. We can see that the sum is 8. We just don't know how we get from the 3 to the 8. So how long should that other arrow be? Well, if we're going from 3 to 8, how do we get there? What do we have to add to 3 to get to 8? That would be 5. So it should be 5 units long. So 5 units. Hopefully you guys can see that, maybe. 5 units is how long it should be. So for B, for an equation that goes with this diagram, my writes 3 plus question mark equals 8. Tyler writes 8 minus 3 equals question mark. Do you agree with either of them? So if we think about this, what my did is she's saying 3 plus something gives us 8. Essentially what I said as we started to figure out 5. So do we agree with that? Yeah, that works because we know we have the 3. We need to add something to get to the 8. So we agree with my. Need to know what to add. So that's essentially what she's looking for, is what do we need to add? So we agree with my need to know what to add. But isn't Tyler also correct? We know that 8 is our final answer and we have the 3. So if we subtract those, are we not also going to get 5, the change between them? Yes. And it was Tyler. So we also agree with Tyler because it's an equivalent equation. Which leads us to what your keyword for the day is. Let me pop over to the sides. Hopefully you can see that better. So your keyword for today is equivalent. Equivalent. All right, for C, what is the unknown number and how do you know? Well, we know the arrow needs to be 5 units long, which means that the number is also 5. So the change is 5, and the overall answer, the unknown number, is 5. So just like we said, in order to go from 3 to 8, we have to add the 5s. That's how we know that 5 is the unknown number. All right, so number 2. Here are 2 more unfinished diagrams that represent sums. Sorry about that. So if we look here, we start at -3 and we're going to end up at 8. Oops. And for the other diagram, we start at +3 and we end up at -8. So for each diagram, we want to write the equation that Mai would write if she used the same reasoning as before. So for that first one, we were starting at the -3. So she'd start with -3 plus question mark equals our final answer of 8. For the second one, we start at +3. So she put +3 plus question mark equals -8. So those would be her 2 equations. And let me make this a little bigger so you guys can see that. Sorry about that. So we have -3 plus question mark equals 8, and 3 plus question mark equals -8. So those are the 2 equations that Mai would have wrote. Now, part B is asking what equation would Tyler write if he used the same reasoning as before. So for the first one, remember before, he started with the final answer and then subtracted the starting value. So that means he's going to start with the 8 that Mai ended with and then subtract the first number. So minus the negative 3 equals question mark. So for the second one, he'd start with the negative 8 and then subtract the 3, that's positive this time, to get the question mark. So that would be how Tyler would do it for this one. So for C, how long should the other arrow be? So if we look at my equation, just to look at it, or at Tyler's, depending on which one you prefer for solving these and thinking about them, negative 3 plus what is going to give us 8? Or 8 minus negative 3 is what value? Well, it's 11. So 11 minutes long. Now, for the other equation, we have negative 8 minus 3, or we have 3 plus what equals negative 8. Well, in this case, it's going to be negative 11 units long. So those are our two arrows then. They're going to be 11 units long and negative 11 units long. So essentially 11 units long for both of them. All right, for D, what number would complete each equation? Be prepared to explain your reasoning. So it will be 11 for both of them. Well, 11 and negative 11, sorry, just like before. All right. Okay, so for number 3, let me bring this so you guys can see it. Number 3, we want to draw the number line diagram for negative 8 minus negative 3 equals what, and then figure out what the unknown number is and how we know that. So we have, let's see where you guys see here. We have our number line. Here's our negative 8, negative 7, 6, 5, 3. So we've got our number line here. Now we have negative 8 minus negative 3. So negative 8 minus negative 3. So what does that leave us in between there? So leaves us with 5. Now it'd be at a negative 5. So our value would be negative 5. Makes sense? So another way to do this is we have our number line. 0, 1, 2, 3, 4, 5, 6, 7, 8, 6, 5, 4, 3, 2, 1. Since this is being based off of Tyler's method, he takes the final number, so this is our final number, and then our starting number, so he starts with the negative 3, then we need to figure out how much longer this arrow needs to be to get to the 8, and that would be the 5 units. So that's how we know that it is a 5-unit long arrow, which means the value is negative 5. So the unknown number is negative 5, and we know that because it's a 5-unit long arrow pointing to the left. Alrighty? All right, so the next thing we're going to take a look at here quick is we can add instead. So we want to match each diagram to one of these expressions, and I'm going to shrink myself down nice and small here. Okay, so we have 3 plus 7, 3 minus 7, 3 plus negative 7, and 3 minus negative 7. So we want to figure out which of these diagrams goes with which of the expressions. So for A, we have 3, then we added something to get to 10. So which one of these, if we're at positive 3 and we add something to it to get to 10? Be the 3 plus 7. Now this next one, we have negative 7, and we have a final answer of 3. So this would be our 3 minus negative 7. All right. For C, we have 3, and then we're going down to get to negative 4. So in this case, we've got our starting value is 3, but then we're going to the left with our next value, and the result will give us -4. So we've got this one here because we started out adding it. So we got 3 plus -7. And so by default, the last one is 3 minus 7. Since the 3 is there like this, and we have the full 7, so that's taking out that. So it's just the portion to the right left over for our 4. So for number 2, which expressions in the first question have the same value? What do you notice? So 3 plus 7 equals 10. 3 minus -7 also equals 10. So these two are the same. But then these two, both are going to give us an answer of -4, so they're also the same. So we should notice that subtracting a number is the same thing as adding its opposite. So just like what we see right here, if we do 3 plus -7, it's the same as doing 3 minus 7. -7 and 7 are opposites. So that's equivalent. So remember, equivalent is your key word for this lesson. All right, in our last little bit, we want to complete each of these tables, and then what do we notice? So I'm going to blow this up nice and big so you can see. All right, so 8 plus -8 equals 0. 8 minus 8 equals 0. 8 minus -5, 3. 8 minus 5, 3. 8 plus -12, -5, and 8 minus 12, also -5. -5 plus 5, 0. -5 minus -5, also 0. -5 plus 9, 4. -5 minus -9, also 4. -5 plus 2, -3. And -5 plus -2, 3. So remember, anytime we have minus a negative, it's the same thing as adding that value to it. So what we should notice is that subtracting a number is the same as adding its opposite. So let me write that out on here. Oops, not that. Subtracting a number is the same as adding its opposite. That is crucial to know. All right, so remember, your keyword for this lesson is equivalent. I hope you have an excellent day. Bye, guys.